We'll go to correct first. So if we get that going on and get to here, I believe this is where we're going. Well, let's get the corrections done and out of the way, and we'll get on with what we're doing today. Now, a couple of announcements before we get there, though. Today's the 8th, okay? Next Monday, we are off because of Martin Luther King. That's the 15th. Monday after that's the 22nd. That's a 2-hour early release, and it is the Monday of finals week. A week from this Friday, well, I should say a week from this Friday, actually Thursday, you have really nothing. I don't know why I'm talking about a week from this Friday. This week, you have Thursday, the Chapter 6 test. And some people are asking, why is it Thursday instead of Friday? Well, quite frankly, I'm done with all the material we have to go through. Okay, that's thing one. Thing two, Martin Luther King weekend has a tendency to have, especially the latter part of my day, people leaving early. And it's kind of a problem to make up tests and actually to take a test 5 days, 6 days later from when you come back. And it's in your best interest to take it before you go, so I structure the stuff that way. Okay. We start reviewing on Friday. That's chapter 1. And then on Tuesdays 2, 3, 4, and 5 is next week. Monday is 6 again, that following Monday. And then I do a kind of a practice test on Tuesday and Wednesday. And then we have the chapter review. Every year I do this. If you are taking off because you got this down, no problem, you do not do well on this final, and it is a final that people change their grade or save their grade on. If you decide to take the time off, and people go, what can I do about my grade? I went, dude, you're like one of 5 people that I witnessed doing nothing in class, and your grade was very poor on that test. Nothing. Way to go. You've achieved what you wanted. Nothing. You don't prepare for it, you will do poorly. If you prepare for it, you will do well. Just make sure that you are following up and asking questions. It is final. It's the final. It moves on. That's why it's 10%. Like all the other tests that you got for the semester. You got 7 tests for the semester. Each one's worth 10% to your final grade. Okay. Today, we're looking at this answers. And the first things, you got this going on. If I can get to the right page. We have scalene, and isosceles. That one's scalene, isosceles. Any questions about them? Now, I should see work about supportive work, the lengths that you're supposed to find. If I just have answers to those and I don't have the supportive work, you will not get any credit for the entire sheet. I will stop looking at it from page 1. Because if page 1 isn't the way I want it, the rest of them won't be. I'm not going to waste my time. Please don't waste yours by handing me junk that is unacceptable. Okay, now the next thing is 4 you're supposed to skip. 5 and 6. 5. If I'm looking at my points SP, PA, AT, and TS, I notice after I graph those lengths are 1, 3 counts. Do you know what I mean by that? That the triangle for each one of those is 1 and 3 or 3 and 1. The side measures are the square root of 10. If all 4 sides are the same measure, it's a rhombus. It can't be a square because they're not right angles. Okay, and I actually checked that with slope. In 5 and 6, it's a rectangle. And I just check, because I already know it's a parallelogram. So I check consecutive sides if they're perpendicular. And I do that with slope. And if their product is -1, then it's a rectangle. In 7 and 8, 7, not, I want to emphasize, not congruent. In 8, they are congruent. Okay, all the sides measure out. They're the same measure. In 9, we skipped. 10, ABCD is not a rectangle. I did that by talking about slopes. I found the slope of A to B and the slope from B to C, and I multiplied them. Their product is not -1, so they are not a result of a right angle. If I don't have one right angle, I have no right. I don't have to worry about any other right angles. Okay. In 11, it's point D. In 12, I should have the work shown, not just something circled. X is 12. In 13, PS, segment PS is the smallest side. In 14, X is equal to 2.5, because it's an isosceles trapezoid and the two sides are equal. And consecutive angles between bases are same side interiors. So now I know that the base angles are congruent. 2 and 3 are the same, 118, and 1 and 62 are the same. Okay. And then the last two, 15 and 16. Circumcenters. Circumcenters are found at the midpoint of right triangles. I should have the triangles plotted and the work of midpoint to show what those midpoint of the hypotenuses are. And I've got a midpoint of 3, 2 on 15 and a midpoint of -3, -4 on 16. You should be showing me the numbers that you added together and divided by 2 to find those. And that's it. Are there any questions that I missed? Anything you'd like to go over after we compared with our row partners? Okay. So let's get on with today's notes. And a little FYI, all these assignments are due tomorrow. Okay. If you do not have the proper work shown on page 1 on any one of them, I'm just gonna call you back when you're finished. Okay. And I will go over it with a more of extreme prejudice the next day when you get them done, because that's when they'll be due. Okay. Determine whether or not, I lied. Today we are looking at that. And our objective to name coordinates of special figures by using their properties. Now these coordinates of special figures, okay, not only naming, but using coordinates that are not numbers. We're using letters as coordinates today. We're finding coordinates of vertices using letters. Yes, you're using letters as coordinates. I want to make sure that's emphasized. And when we do this, we set them up in a way that it makes more sense. We have dimensions of our shapes that help us set up these coordinates. But we have to be willing as students to break things up, to cut them in half, to see how things work coordinate-wise. So in this first one, before I even start, if I was going to make a rectangle with base 10 and height 3, base 10, height 3, and I have it centered here, what's half of 10? 5, okay? So I got this is 5 and this is 5. Height is 3, okay? I have dimensions. I have numbers here now. How would I find this point on the XY coordinate grid? I start at 0, 0, and I go to the right, how many units over to the right? It's quiet as a church. Are you okay with 5, 0? I go over 5, 0. And because of symmetries, and I have it in the center, I go back -5, 0. And I would go -5, and I'm going up. My height, what's my height in this figure? 3. Does that make sense? So 3. And over here I go 5 out and 3 up. So I have my dimensions help me find my coordinates. And a lot of times after I do that, I go, oh, okay, I get that. But now on this next one, I'm going to have you do letters. So I know the dimension is 2b. They tell me that right here. CD is equal to 2b. They tell me further that my height is h. Can we find the coordinates of point C? So the first thing is, what's half of 2b? Okay, so I got b coming out. So I've got b out, and since it's on the axis, what's my y value? It doesn't go up, it doesn't go down, it just sits there. What's the value of that? You okay that it's just 0? That's that one. To go from there to b, I go out b, up how far? Are you okay with BH? I go out B, up H. Out B, up H. Because my dimensions are there. This is 2b by h, half of b, so from my 0, 0, b0, bh. Now, reversing it, what happens when I reverse it? How do I get to the left? What do I got to do with my x value? Yeah, take the opposite of it. Okay, so I've got opposite of b and 0 for d, and opposite of b, 3. Okay, are you okay with what I just did? No, I can't believe I just said 3. I just used that upper example. H. Okay. Are you all right with my coordinates? Now, in this problem, I was just supposed to say, hey, you know, I was supposed to answer B, and I was supposed to answer 0. But I find that the more often I put this in front of you guys, the quicker you start getting it. Okay? Right now, it's okay to be a little lost, but not okay to stay there. So make sure you start asking questions on the next one. And this next one, I kind of want to walk away from this for a second, but you got to make this change. That's got to be H. Okay, and this change, that's got to be N, A, H. If you already got it, please make the change. Please make that change. Now, please keep in mind, this works because we pay attention to dimensions provided to us in the problem. We are given that I've got a dimension that's h high, and the distance of one side is p long in this, or point P is b long, and I've got h high. Now, before I get to this one, I want to talk about one with numbers. You do not have it in your notes. I just want you to watch it. Okay, don't add it to your notes, just watch. Now, do you see this value, this out and up? Okay, this part is at 1 right here. If I go out and up, n starts at 1, 3. The height being 3. Did you notice that that's how high it is above the x-axis? So my height is 3 on that figure that I've got it as an example. I have my length from the origin to P as 5. So my P coordinates are what? If you were going to be on the phone with me and go, Bloom, the P coordinates are at 5, what? Any ideas? I got a bunch of blank stares. If you were going to put this in as an answer, what were the numbers that we'd put in there? 5, 0. Okay. So I got 5, 0. Now, everybody's like going over here, that's 0, 0, and they're happy. And I got 1, 3. I got to know what these two values are. Ideas. Anybody got an idea? Yep, Faircloth. 5, 3. Now, here's the thing. I like the idea of 3. That's high, but 5, 3 is right there. I'm shy a little bit, right? I like 3. 3 works. Okay, but let's talk about the 5 thing. If it were a rectangle, it would totally work, but we have this kind of pushed out already, right? So that's already 1 unit forward. So that's 1 ahead right here. So if I had like, oh, if we're going to run track or something, you know, the staggered start, you know, I have that person 1 forward, but to be fair, so we all finish at the same time. You know, because they're running on an outside lane. How far do I have them running? I have them running 5. So if I stagger it on a corner, I should stagger their end unless I have to do another corner. And so what should the Q be really away from, what's my distance away from the y-axis? So 1 initially, and then I add 5. So you okay that I'm going to go 1 plus 5? Do you see where the 1 comes from and the 5 comes from? So really my answer should be 6, 3 out there. Does that make sense? Now I point this out because this is a hard idea to get. And the 1 came from the separation right there. Now, what we're about to do is something that's very similar, except remember, I just made numbers up here. I don't want you to make numbers up. I want you to use the letters, okay? But I did this so you could see what happens number-wise. The same experience happens letters-wise, okay? So now, with that said, I want you guys to fill in, and I'll take this one because that was the hardest one. Whew, okay, I got that one done. Now, with that help I gave you, with that, I want you guys to fill out P and Q. So find P Find P, find Q. And actually commit to a value so we can fix your understanding at this point, okay? I'll give you like 30 seconds to just think about those. And it's very similar to the one we just did. Ideas for P. Anybody want to commit to a value for P? I'm just going to pick on people, Miss Smith. B0, perfect. Because I go out B and don't go anywhere, so B0 works. Okay, is it okay? Any takers for Q? Any take, Levine? A plus B. Why A plus B? You have to take the A value we have at N and you have to add the B value with the entire length. Love it. So A from N and B the entire length are put together, and then we still have our H. Fantastic job and great explanation. Okay. Now, here's the thing. That's what we're doing. Okay. So we took our dimensions provided from the problem and we transferred it into an XY coordinate plane coordinates. So now just make sure after we write those in that we don't screw up the blanks, okay? That we put them in the right spots. Now, with that done and said, I'm going to put some restrictions on this next one, and you're going to do more of it than I hope. You guys got 4A for this whole length, and you got 2B for that whole length. Knowing those things and knowing that it's centered on the y-axis, that y-axis is cutting that sucker right into 2 equal parts. I want you to come up with the coordinates. Okay? And remember, cutting something in half is the same as dividing it by 2, so that might be a hint to what your coordinates should be. So give it a try. And on this one, after you're done, I want you to compare it with your row partners, please. Now reread, oh, by the way, the height here is C. They changed the letter for height for C. I'm going to mess around with that a lot just so you pay attention to reading the problem. The height here is C. And I kind of covered it up, but I think I did a better job of cleaning it up on your copy. My copy is not so good. Okay, so what's half of 4? 2. So I'm out here at 2A C. If I do that, can you not only check to see if you did yours right, but now clean up the mistakes you may have made on the others? Down here at M, I should have a negative B0, because that's half of 2B is B, okay? I should have a negative 2AC and a B0 there. And again, popping those in, that's what I should get. How you doing? Okay, I've got some good head bobbles. I got some thumbs up. Okay, right now, out of 8 points, if you're sitting at 6 out of 8, 75%, that's pretty awesome. If you're at 7 out of 8, wow. But our job is to make sure we notice what our mistakes are when we do this. That's why we practice. We don't practice just because Boom wants to waste time. Okay, better things to do for both of us. Okay, I'd rather watch you guys like have an opportunity to watch grass grow than actually do examples to waste time. So make sure you start noticing what you're doing to set these up. If you make a mistake, more than likely, that's the most typical mistake you're going to make every time we do one of these. So let's double check them. Most of the time it's a sign error. Let's look at the next one. Now, in this one, I'm asking you to look at the diagram. The diagram shows a rectangle with base A and height B. And I have A and B put into the diagram. I want you doing that as well, so it kind of reminds you what you're doing. And instead of having it centered around the y-axis, you know, like we did before, I moved it all so now it's kind of right on that 0, 0 for the origin, okay? So now my dimensions will be more helpful with my coordinates when I don't have like 4a, 4b or stuff like that. It's not evenly divisible. But I want this one to come out, and there's a couple ways to get this answer, but this one that I want you to see that if we properly set up the problem's coordinates based on the dimensions provided in the problem, we can use it in formulas and our results will make sense. Okay, and without an example, it's tough to explain that any further, so let's do the first step. Step 1 should be find the coordinates of my rectangle that's now moved. So let's find the coordinates based on my dimensions. So I have A out, B up, okay? So based on that description, you notice how I do A out, B up. Come up with the other parts of the coordinates, okay? And after you do that, and I've got them in there, I've got kind of, you know, like, if I go A out and B up, I'm going to let you in on a secret. H becomes AB. I ain't doing anything secretive. A is X, B is Y. From there, you should be able to get the rest of it. So get the rest of the coordinates listed. List them out actually on your diagram. I find that if you do that, it makes the most sense because you start thinking about how the diagram relates to the coordinates themselves. Sometimes we won't give you a diagram, but you should draw a diagram. Oh, I'd hope to see math there. Okay, you ready? Are you okay that this is 0, 0? Are you further going along that that's A0? And then we got 0B. Because if you're getting those, if you're firing on all cylinders there, we're doing pretty darn good right now for problem 3. Are there any follow-up questions with the positioning of my coordinates based on dimensions provided in the problem? Okay, are we doing okay? Base is always left to right. Height is up and down, okay, when we do this. Now, what are the coordinates of D? The point of intersection of the diagonals of a rectangle GHIJ. So we already got D listed there. And the way we set up our coordinates is going to help us with our solution. So now I've got GI, that's the first one. I've got 0 plus A divided by 2 and B plus 0 divided by 2. And I color coded them so you know that I'm working with the X's and the Y's from each point. Okay, the X's of are added together in the first part and divided by 2. The Y's are added together in the second part. And I do the same thing in the next one. But so I'm going to do this. And now if I was careful about my dimensions they provided, they're the same letters, right? And now if I really think about A plus 0, isn't that just A? And B plus 0, isn't that just B? Okay, so I should come up with solutions that are A over 2, B over 2, and A over 2, B over 2. Now I've got some people thinking, oh, Bloom, you just did the same problem. I just took my 2 different sets of coordinates along the endpoints of my diagonals and found their midpoint. Now, keep in mind, they're asking me here, what are the coordinates of D? They're not asking me to prove anything. They're asking me to find the coordinate of the midpoint. Now, in doing this, because they happen to have the coordinates of the midpoint the same, I'm saying that the midpoint of both diagonals is the same spot, which extends to the idea that I have diagonals that bisect each other. That's what I have right here. Two diagonals bisect each other, have the same midpoint. They have the same midpoint, so I can prove that this four-sided figure is a parallelogram. Okay, I could further go on and say, hey, it's a rectangle by just noticing that I've got one set of right angles because I've got a horizontal and vertical line coming together, and by definition, those are perpendicular. Okay, and once I have one perpendicular angle, I have four perpendicular angles in a parallelogram. And remember, I proved it was parallelogram because the diagonals bisect each other based on this. Okay, so, but I was just asked for what D was, but I'm extending that idea to both sides. I only had to do one of those, by the way. I wanted to show both so you could see that if we set up our coordinates based on dimensions, it wouldn't matter which one we came up with. Okay. Now, next one. I want to plan for a coordinate proof that was much like what we just did. Name the coordinates of Pythagorean theorem, parallelogram ABCD at the right with base B and height h. Now I just gave you dimensions. The base is B, the height is h. I have a picture. I've got ABCD in that XY coordinate grid. I want you to assign coordinates to it. Okay? I've got points, A, B, C, D. Assign the coordinate names. You know, the X, the Y coordinates based on the dimensions I provided. Go ahead and do that on the picture, and then we'll transfer them after we talk about them. Okay? Go ahead. This one, by the way, very few people have missed any more than one set of coordinates. So this one should be the one we're trying to do our best on. Just reading. Trying to kill me. Okay. All right. So here's the deal. I've got D, 0, 0. Okay. Has everybody got that one? My dimensions. They say my at the right with base B, height h. My B is the narrow part. So I go B0. Are you okay with that? And now my height is h, so BH going up. And since it's on the y-axis, it's 0h. How'd you do? Is it making better sense? Okay, so remember, we've evolved a little bit. We're starting to get it. We're starting to get it, I hope. Okay, now, in this particular one, as I transfer this, I want you to reread the question in 5 as I read aloud. Plan a coordinate proof to show that a parallelogram is a rectangle. So they gave us that it's a parallelogram. They gave us a parallelogram ABCD. They want us to prove that ABCD is a rectangle. That's all I'm doing right here. That's it. People are like, how did you know? I go, I reread that. I might have read it 2 or 3 times to set up my problem. Okay? Now, I want to alleviate people's stress. I'm not going to have you do this as an assignment, but I do want to show you how we can use coordinates in a coordinate proof setting. Now, it might seem that I really cut this off, and I did, and I apologize for that as far as giving you space. So you might want to be working on the next page, not on my like problem C. In that right column, in the right margin, left margin, you might want to put information from part C because it's kind of long, and I apologize for that. But I wanted to be as clear as I could to make sure you recognized how it all works. Now they ask for what information do I need? Okay, What information do I need to prove the parallelogram is a rectangle? Well, there's two pieces of information I can use separately. One, okay, the diagonals are the same measure. Two, the slopes have a product of -1, or that I have a vertical and horizontal line coming together and make a right angle. So that's what I've got up here. Those are the two things that I need. And that's my answer, okay? But, you know, I felt it was important to show how that answer is achieved, okay? Because when I'm doing this type of problem, some students kind of think, oh yeah, that's the answer, that's what we're gonna do. But this is a coordinate proof type problem where you set up the coordinates based on dimensions. And if I use my smarts and I set up the dimensions correctly, there's two ways that I just said we're going to do this on. Way one is over here, way two is over here. Okay, and I want to show you both. I only need you to write down one of them. Okay, so if you can remember one of them, write down the other. Okay. But I don't need you to have both down. But that's why I mentioned the margins. So when I'm looking at this, I've got slope of AD and the slope of A to D. If you look at slope AD and the slope DC, I notice that the slope of AD, that's a vertical line, right? And the slope of vertical lines is undefined. And the slope of DC, it's a horizontal line. The slope of horizontal line is 0. And it is determined when we did chapter 3, section 8, that slopes of vertical lines are undefined, slope of horizontal lines are 0, and we defined where they intersect is a right angle. We did that in chapter 3, and we've been using it ever since. Okay. Now, I have talked about parallelograms that have a right angle at one vertex. Because it's parallelogram, opposite angles are congruent, so there's a right angle at the vertex opposite it. Because it's a parallelogram, consecutive angles are supplementary, and a right angle is 90 degrees, so 90 plus 90 is 180. And consequently, that's right angle, and the angle opposite that is now a right angle. So once I have a parallelogram with one right angle, it has 4 right angles. Okay, and the reason why I'm saying that is enough information for me to say, hey, look, I've got a right triangle. I'm not a right triangle, a rectangle as I go through this. So I've got ABCD is a rectangle by definition for my steps. And some people, boom, you didn't have enough information. I just said, hey, I got to prove there are 4 right angles, and I'm showing you how I do it. Okay. Now I also said, hey, I got to prove that diagonals are congruent. Now I just want you to watch this one because we were careful about setting up our coordinates, right? Because I was careful about setting up my coordinates, when I do this diagonal A to C, I got OH, 0H, and B0. Well, if I plug those in, what's 0 minus B? And some people go, well, 0 minus B, Bloom. No. What's 0 minus 2? Isn't that -2? 0 minus 5, -5. 0 minus B, -B. Okay? And I got H minus 0, just H. But if I take 0 minus B, which is -B, and I square -B, what do I get when I square -B? -B times -B is B squared. Okay? H times H, H squared. I add them together, take the square root. I just found the length of AC, the diagonal AC. Looks like a shortcut to the Pythagorean theorem, or using the shortcut with diagonals. But now I have my other point, which is 0, 0, and BH. Well, I put it in my formula, 0 minus B again, 0 minus H, and I get B squared and H squared. It makes sense, right? But because we were so careful setting up our coordinates based on our dimensions, we can now look at these two values, AC and BD, and say, hey, those are equal. Not only is this a parallelogram, but it's a rectangle because in a parallelogram, if the diagonals are the same length, you can determine it's a rectangle. Okay? Are there any questions about that? Now, that was example 5. We got 5 left, and they take less than 10 minutes to do. In 6, I want you to notice that QS is centered on the origin. RT is centered on the origin. And people are looking at this like, why did he decide to do this? This is the easiest way for me to show a rhombus centered on the origin on an XY axis to make it easier for me to do the dimensions, use dimensions to get the coordinates. So if I know QS is 4R, and if I know, wow, that's kind of big. Let's make that a little smaller. That RT is 4T. What are the coordinates of my vertices? And so this kind of transfers to this being 2R, and this being 2R, and this being 2T, and this being 2T. And people ask, where did you get those? I got them from the problem over here on the left. Find your coordinates. Go ahead. Remember, those dimension things I put out is the length of the diagonals. I don't know how else to show it than just to put them in there the way they gave them to me. Now, if I'm looking at S, are you okay that's 2R, 0? You okay with that? And if I'm looking at Q, isn't it negative 2R, 0? And if I'm looking down here, isn't it 0, 2T, negative 2T, excuse me. And up, isn't it 0, 2T? You notice how I did that on the diagram so I could make sure things made sense? And then I'm going to transfer it and make sure I put it in the right spots so I don't screw up a free lunch. Okay? Are you okay with these points using dimensions they provided? We're good? Last 4 questions. Find D. Go. You may make the assumption that this point here that's on this segment that's on the x-axis is evenly split up by the y-axis. So find point D. Find point D. Now, hopefully you're starting to pay attention to symmetry. Since that negative A0 is over there, point D should be A0. So we should be going there and there. And now we've done this parallelogram. This will be the 3rd time with letters, the 4th time just looking at a parallelogram and thinking, all right, what's point D? Remember, it starts out by B and it's A long. So that's where I'm getting B plus A or A plus B, C. Are you okay with that? Yes or no? You're feeling okay with that? I got head bobbles. Things are going all right. Be careful about order. Order matters. If like in 7 you decided to go 0A, they're wrong. Okay? Well, I had the right letters. Someone's, oh, well, great. But you have them in the wrong spot. So order matters. Okay? A plus B, you could have gone B plus AC or A plus BC. I don't care which one, but it has to be those first in the X value. Any follow-ups there? Now, go ahead, get after this next one. Okay, you have a square that has all the properties of a rectangle. I say that because rectangle diagonals are congruent. That's my hint for 9. Rectangle diagonals are congruent. That's my hint for 9. Okay, so I go out to A, and I go up to A to get there. Now, some people are like, how do you know? Because this is 2A long, because I would go out to 2A and A up. Okay? So my dimensions help me with my coordinates as I'm looking at the problem. Properties come in play as I look at the problem. That's why you're told that it's a square. That's why I'm told that it's a rhombus. And this one I had to look at both diagonals in number 9. In number 10, I look at the single solitary diagonal of each one. Because in this one, if I go out B, it's 0. I go back B, it's 0. So it's 2B big. This one I go 0 up 2A, so I should go 0 down 2A and get this one. Are you okay with how I orient myself with the problem, the coordinates of the problem, or even dimensions of the problem to find the missing values? And I'm still running through those properties. What's a rhombus? Diagonals bisect each other. They're the same lengths on the same diagonal. Square rectangles have the same length diagonals. And I use those when I'm supposed to. Remember, they change by problem. Today's assignment, as we do this today, it copied kind of funky, but that's okay. I wasn't going to give you that much more than what I have out here, and I'm going to give you what I'm going to give you. I've got problems 1 through 10 today. You just have one more problem for tomorrow after we do notes. Notes tomorrow, 11 and 12 from our notes, will be completed, and then we'll do problem 11 together in your assignment packet. And then we'll be done with all material for chapter 6. Now, please know that the test is Thursday. Tomorrow we start our review. It's an online review, okay? You can reopen and come back to. As far as I know, I'm hoping that you can do that the way it's set up, but I'll double check that to make sure I haven't screwed that up. But make sure you are taking care of your prep. Make sure you have been taking care of your note card, the quad flow chart we've done together on the front. The back, you can fill up with anything else you need. Okay, people always go, hey, is this a good note card? I don't know. I don't know what you know and what you don't know. I just know as you go through chapter 6, if you reread your notes, you go through the assignments I've let you keep, make sure that the information on that note card helps you do all those things. Okay? All right, time is yours. We've already corrected. You got 8 minutes, and in 8 minutes, people have finished the assignment I provided today, 1 through 10. Okay? Thanks, guys.